Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, determine the domain of the function f of x equals the square root of x squared minus 25. So this function has a square root in it. So how do we find the domain if there's a square root involved? Well, you're going to set the radicand, which is the part underneath the square root. In this case, it's x squared minus 25, greater than or equal to 0, and solve for x. So why greater than or equal to 0? Because you cannot take the square root of a negative number. The number underneath the square root must be 0 or positive, which means it must be greater than or equal to 0. So let's go ahead and set the radicand greater than or equal to 0, and then we will solve for x. Now you might be thinking, I'm going to move the 25 over and then take the square root of both sides. So that cannot be done. So it's really important. That's an illegal move in math. You cannot, whenever there's a quadratic or there's a fraction with an x on the bottom and an inequality, you cannot just solve for x like you normally would when there's an equal sign. So how do we do it? Well, we factor the left side. So x squared minus 25 is the difference of two squares. So that becomes x minus 5 and then x plus 5. And we have to utilize a number line to graph our critical numbers. All right, so here the critical numbers are going to be where this function here equals 0. So looking at each factor, we can just set equal to 0, and those are going to be our critical numbers. So we add 5, we get x equals 5. Then over here, we subtract 5 to both sides, so x equals negative 5. So now we're going to bring up a number line here, and we're going to put our critical numbers here, negative 5 and 5, on our number line. So we have negative 5, and only those numbers. Really important. I always tell my students, only put the critical values on the number line. Do not put 0 or any other values on here, unless 0, of course, is a critical value. All right, next we want to test each of these intervals. So there's 3 intervals. This interval between negative 5 and 5, and then from 5 to infinity. So what we're going to do is bring up a t-chart. We're going to plug in a value in this interval. So I'm going to plug in negative 6. And then a value in this interval, which 0 is a great value. Whenever you can plug in 0, always plug in 0. And then on the right here, I'll just plug in 6. All right, so now if we plug in negative 6, we're going to plug it into this guy here. You could also plug it here if you wanted to, but I'll plug it here into the factored form. So if I plug in negative 6, I get negative 6 minus 5, which is a negative number. And notice I only care about the signs. And then negative 6 plus 5 would also be a negative number. So a negative times a negative is a positive. So that tells us in this interval here, it's going to be a positive. Any number you plug in from negative infinity to negative 5 will give a positive value for this. Next, we plug in 0. 0 minus 5 is a negative number. And then we plug in 0 here. 0 plus 5 is a positive number. A negative times a positive is a negative. So that means this interval here, any number you plug in between negative 5 and 5 into here is going to yield a negative number. Next, we plug in a number here, which is 6. If we plug in 6, we get 6 minus 5, which is positive 1. So I'll write positive here. Times then 6 plus 5, which is also positive. So we get a positive value. So we go here and write positive. All right, so now we have to decide which ones of these intervals satisfies the inequality. Well, we want the product of these two factors to be greater than or equal to 0. So that tells us that we want the product to be positive. So that means this interval and this interval here satisfy the inequality. So notice there's tons of numbers. There's really an infinite number of numbers that would satisfy the inequality. So that tells us that our domain is, we'll do this interval first because we always move left to right. So it's going to be negative infinity to -5. And then does it include -5? Well, you kind of have to plug in -5 here to decide. So -5 is -10 times -5 plus 5 is 0. 0 times anything is 0. Is 0 greater than or equal to 0? Yes, it is. So because -5 satisfies this inequality, -5 works, which means we put a bracket around it. Next, we do this interval, so union with 5 to infinity. And for the same reason, 5 will work as well, because if you plug in 5, you'll get a 0 here. 0 times anything is 0. And again, 0 satisfies the inequality. All right, so this is an interval notation. How about, let's write our answer in inequality notation. So I'll put an or here. So this will be x is less than or equal to -5 for this interval. So less than or equal to -5, or, and then the interval over here is x is greater than or equal to +5. All right. So there is our answer. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.